Welcome guys, welcome to DSA training. Today we will see some of the logic building problems, and the first basic problem is here. Given a number n and check whether it is even or odd, and I am doing this using Google Colab. Uh, Actually, you can do it in any of the environments, like you can do it in IDLE, or you can do it in Notepad and then compile it, or you can do it in Jupyter Notebook. But I am choosing Google Colab because without installing any other software, we can practice Python in Google Colab. You can simply type Google Colab in your Chrome and you will see a open notebook, new notebook. Then here you can add code or text. Here I have predefinedly added this text. Now let's see the first problem. Given a number n, check whether it is even or odd. So here is a hint. How can we check whether a given number is even or odd? By dividing it by 2. If the remainder is 0, when divided by 2, if the remainder is 0, then we can say that it is an even number. For example, take 44 as example. If we divide 44 by 2, what is the remainder? 0. Here percentile symbol indicates the modulus operator, that is, it gives the remainder. If we divided 2, if we divide a odd number by 2, then it gives 1 as an answer. So let's start coding. First, let us take an input n. N is equals to input of what this function will do. It will take an input from user. Then what should we do? We have to check whether the given number is an even or not. How we will check that? If n percentile 2 is equals to 0, means if the remainder is 2, then what should we do? Print even number. It is an even number, like that. Okay, then what is the other case? Else what should we have to print? Print odd number. In most of the coding platforms, they will not allow the input statements and the output statements, that is, taking input from user and printing the output. They will just give they will just ask us to give the logic and return the output. For example, they will give a function which takes n as input, and they will say that if it is an even, return 1, else return 0. So here in place of this statement we will return 1 and here return 0. So let's execute this and see whether it is working or not. It takes some time. So yeah, it is working. It is asking for an input. Let us give 4 as input. See, it is giving even. Let us run it again. Now we will give 75 as input. Enter. It is giving odd. I mean 75 is odd. Here we have told it right. If it is not, print odd. That's why it is printing. Let's take another input. Let's take a big one. Now see, it's giving odd. That's right. And a simple input like 8 even. And let us this is an easy approach, but in DSA we have to know about the efficient approach. So what is the time complexity of the above approach? Can anyone guess? Time complexity. Time complexity is represented by big O notation. Means like this. In inside the parenthesis. Now see, it is just taking the n and it is just checking whether it is even or odd. It is performing only one operation. After that, based on the operation, it is just printing. So it is the constant output means what is the time complexity? Order of 1. And what is the space complexity? Space complexity is also order of 1 because here we are only using one variable, that is n, to store the number given by user. So how much amount of memory is required to store it? 4 bytes because it is an integer data type. Since we are using only one number, that space complexity is also order of 1. So in DSA we will learn about efficient ways, not a brute force approach. Here this is a brute force approach. Also we uh, call it as Nave's approach. Let us see an efficient way. I am telling you now that for a single problem there may be multiple paths. Some may be efficient, some may be inefficient, some may be cheaper, some may be costlier, and very path. So what is the another way of doing whether a number is even or not? And the other way is bitwise operator, using bitwise. And let's see some interesting thing. Let me take some text box and I will show you. So here, see, mm, let's perform the bitwise operation 5 and 1. What is the answer? 5 means 101 and 1 means 001. What is the output for this operation? 1 and 1. It gives us 1. And 0 and 0, it gives us 0. See, here we are performing the AND operation, bitwise AND operation, and 1 and 0, it will give us you 0. Means 5 and 1 gives the output as 1. And let us take some another example. 4 and 1. 411 is equals to how much? 4 means how much? 100 in binary notation, and 1 means 001. Now perform binary bitwise AND operator. 0 and 1, yeah, 0. And then 0 and 0, it's 0. 1 and 0, it's 0. That means 4 and 1 is giving 0 as output. 4 and 1 is giving 0 and output. Here you observe one thing. If we may, if we perform bitwise AND operation with an odd number, if we perform bitwise operation with an odd number, then it is giving 1, it is giving 1 as output. And if we perform even number, then it is giving 0 as output. So what we have to do is, let's perform. First take an input from user, and then perform bitwise operator. Means n and 1. If n1 and 1 is equals to 0, means what? It is an even number. It is an even number. Same again. Print even, else print odd. Let's check this function as, code as well. It is asking for an input. Let us give 5. It is returning odd. And the time, this time we will give some big number 976543267. Enter odd. Remember one thing, unlike in C, C++, and Java, we don't have any range for integer. We can type billions and billions of numbers. But in C and C++, we have some limit, right? 65,000 signed, unsigned integers like that. But Python doesn't have those boundaries. And let us see 7. It's an odd number. And let us see 6. It is an even number. And what is the time complexity for these bitwise? Similar to this approach, time complexity order of 1 and space complexity order of 1. But why we are calling this code as an efficient code? Because it is doing bitwise operations. Bitwise operations takes less time than other operations. Bitwise AND, OR, XOR, like etc. takes less time than percentile, into, plus, subtraction, and so on. So let's move on to the second problem for today. What they are asking, they will give us a number n and we need to print its table. It's a simple code even a child can do. Here we will do it in two approaches, iterative approach and recursion approach. I think you know about the difference between iterative and recursion, right? Iterative means looping. Iterative. Iterative means looping. It can be for loop, for each loop, or while loop. Do while will be there? No. No do while loop in Python. Okay. Okay. For each comma while. Sorry for the mistake. And now let's do this iterative approach. Now start coding. First we have to take the input, that is n is equals to int of input of. Then what should we do? We have to use iterative approach, means we have to use looping. So I am taking for loop here for I in range of, here I am taking up to 10 times. I mean from starting from 1 to 10. No, 11. Why 11? Because the second parameter in the for each loop is exclusive, means it will not go until 11. It will stop before 11. If we write here for I in range of 0 to 5, then what is the output? 0. What is the I value? 0, 1, 2, 3, 4. That's it. Here 1 to 11, this is the starting index which is inclusive, and this is the ending number which is exclusive. Now what are the possible I values here? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That's it. Okay. Now let's see the implementation. We have to print, so I am directly printing the table here. Print n, sorry, n into, so sorry, n into into I is equals to n into I. Okay, now let's see the output. It is asking for the number. Let's give 6. Oh, let me just check it once. Unsupported of type of yes for okay, we don't have to use plus here, maybe comma. Let me check it once. Sorry, I think I am in Java mode. Let's see. Let's recompile it once. It is asking for input. Yeah, it is working. It is giving me the 6 table. Let's give another table 97 and see, it is giving the 97. And here I is incrementing every time. That's why we are saying that for each loop first it will print n, that means 97, then into symbol, then I value. What is the I value in first iteration? 1. Then n into I means 97 into 1, 97. See, 10 times it is printing 97 and into and I value starting from 1 to 10 and is equals to, and then n into I means 97, 194 and so on. And what is the time complexity here? Here the time complexity. Think time complexity is order of 1. Yeah, space complexity is order of 1 because we are using n one variable and I another variable, two variables. Still two variables means it is a constant, right? That's why space complexity is order of 1, order of constant. And why time complexity is order of 1? So many members will be in the belief that we have used n for each loop, so the time complexity will be order of n. But in this case the time complexity is not order of, sorry, but in this case the time complexity is not order of n, but it is order of 10. Why? We are iterating this for loop, we are executing this for loop for 10 times. That's why it is order of 10. 10 is a constant, that's why order of 1. If in case we have written here 1 comma n, then we don't know what is the n value. It will be dependent on input size, then it will become order of n because this for loop is executing for n times starting from 1. That's why order of n. Here we have used 11. That means it is iterating for 10 times. 10 times means order of 10. Since 10 is a constant, we are writing order of 1. Then let's go to the recursive approach. Do you know about the recursive approach? Yeah. If a function or a definition calling itself again and again, then it is called as a recursive. So first we have to define a function. Why are you defining a function here? We don't use function here, we don't use function here, we don't use function here. Then why are you using here? Because without function, can we define a recursion? Of course, no. Recursion means calling a function. It's calling the itself again and again. Let's see definition. We will name it as multi. Then what are the parameters? N comma I is equals to 1 as default parameter means starting. Now when it should, what is the base case? What is the base case here? If I is equals to 11, return. Why? We want the table for 10 times only. That's why I am the base case is if I equals to 1, return. Else what should it do? It should call itself again and again. Means let me write another thing here. Else what it should do? It should print the current one. I mean, let me copy this so that we are not run out of time. So see here, it will print the n multiplication for one time, I mean one series, and then it will increment I by 1. I plus equals to 1 means I equals to I plus 1, and then it will call itself again and again. That is multi of n comma I. So let's see this. Do you think it will execute? Okay, let me take this out. Yeah, see, no output. Why? We didn't call the function. Here we just define. But when will the function starts executing? It will start executing only when we call, after calling the function. So let me call it outside the function multi of n comma n, just n, because we have used default parameter here, right? And what is my n value? Here I am taking n as input from user. So let's see for output now. See, it is asking for input. Let me give 7. It is printing. How it is printing? Let's trace the code. First time I have passed n as parameter, means 7. And what is the I value? 1. Is I is equals to 11? No. So it is going to the else case. Then it is printing 7 into 1 is equals to 7, and incrementing I by 2 and recalling the function again. So it now n value is still 7, but I value became 2. Since we have passed 2 here, the default parameter will not work in this case. It will become 2 now. Default parameter takes action only when we didn't give the when we didn't pass the parameter. And what is the time complexity? The same order of 10, but iterate. Which one is efficient? Do you think iterative approach or recursive approach? Of course, both of them have their individual advantages and disadvantages, but in this case, iterative approach is more efficient because for this simple problem we are using stack space very much. It is continuously calling its own function. So recursion is used where reusability is allowed. Reusability is allowed, and like in case of trees, graphs, where we have to recursively go for children and all. So in this case, iterative approach is efficient. So that's all for today. For more updates, stay tuned. Thank you for today.